Hello everybody, I'm Nicholas Blanco, working out some problems from the Exam 1, Chapter 6 through Chapter 7. This test made me cry a little bit, but hopefully if I work through this, it won't make you cry. So, to begin, our problem is sine cubed over cosine x with the defining the integral between pi over 3 and 0. So in order to begin, we should start by breaking this integral into sine squared x times sine x over cosine x dx. And then we can apply an identity so that 1 minus cosine squared x is equivalent to sine squared x. Then multiply that by sine x. Then all this will be divided by cosine x. So since if you know our trigonometric identity, sine squared is equivalent to 1 minus cosine squared, just as cosine squared is equivalent to 1 minus sine squared. So we're taking the integral of that. And keep in mind, it is defined between pi over 3 and 0, but for our purposes, we'll just be using integral sign till the end. So the next step would be to distribute the sign, because 1 minus cosine squared x is can be multiplied by sine x, and then we end up with sine x minus cosine squared sine x all over cosine x. Since these two functions are being subtracted, we can break the integral up into tangent x, the integral of that. And don't forget to include our dx's. Subtracting from cosine squared times sine x over cosine x. I apologize if my hand's a little bit shaky. I don't have a camera stand. So then we can cancel out the squared sign here, and it's cosine x sine x dx, the integral of that. We'll come back to this tan x since it is a standard integral and be fairly simple to solve. In fact, we can solve it right now and just say that it's the standard integral of ln secant x. Don't forget to include the absolute value. Then we are subtracting it from cosine sine x dx. So we can write this out actually as sine x cosine x dx, and then we can take cosine x dx as our du and sine x as our u. So by doing so, we've created a u substitution. So after solving for this u substitution, we could create a standard integral of u du, and then we can solve this integral simply, since it's now a linear function, we can solve it as u squared over u du. Something to note with our substitution, cosine stays the same. So our new integral is sine squared over 2. Then we can solve this as ln of secant x minus sine squared over 2. Now, at this point in the integral, we can solve it by plugging in that pi over 3 we mentioned previously. This shouldn't be an integral sign anymore since we've solved for our integral, and we would write this out as such: ln of secant x x will now be pi over 3 minus sine squared x divided by 2, which this x is now pi over 3 minus, let me just adjust my camera here really quickly, minus ln of secant secant 0 minus sine squared of 0 over 2. And then solving this, we get ln of secant 0 being 1, so ln of 1, that can be canceled out. Sine squared is also, sine of 0 is also 0, so we go over here to solve. I've already previously solved this, but just by plugging into the calculator, we get ln of secant pi over 3 is ln of 2 minus sine squared pi over 3, which is over 2 as well, and that would be and checking my notes here, that would be sine squared over 3, which that is squared over there, square root of 3 over 2, which is just 3 over 4 divided by 2, which comes out to 3 over 8. And our final answer is ln of 2 minus 3 over 8, and that is our final solution.